Okay, welcome back once again to all my dear students. Yesterday we had discussed about the enthalpy, that is H equals to U plus PV. Then next point, that is the laws of thermodynamics, that is the zero law. First one, that when the two conducting rod, one will have the more temperature and second will have the less temperature. When they both are come in the contact with each other, then what happen, that the transfer of the temperature will be take place, or the transfer of the heat will be take place from higher temperature to the lower temperature until the temperature of the rod will becomes equal. Understand? That is the law of zeroth law of thermodynamics. First law, that we can say that the energy can neither be created nor be destroyed, and the one form of energy will be converted into the another form. Okay, so all these things we had discussed. Then we had also discussed that if the work is done on the system, then W is positive. Work is done by the system, then W is negative. Right? If during the chemical reaction, if it release the heat, then we can say that Q is negative. But it absorb the heat, then the Q will be positive. Understand? So related to that, we have also discussed some examples also. Right? Now today we are going to discuss the next point, that is the work and the first law of thermodynamics. Let us see that work and first law of thermodynamics. First law of what? Thermodynamics. Thermodynamics. Let us see. Before discussing this, you have to know that what is work. Work किसको बोलते हैं? Let us suppose if any substance is there. Let us suppose this substance is there. If I apply the force is applied at the point where it is applicable, and the point move in the direction of the force applied. ये इस पॉइंट पे मैं फोर्स अप्लाई करता हूं, तो ये पॉइंट किस डायरेक्शन में मूव करता है? तो फोर्स की डायरेक्शन में विल बी मूव, and it can change its position from one place to another place, and that's why we can say that the work is to be done. उसको हम क्या बोलते हैं? Work is done. Right? Basically, there are mainly two different types of works. First one is the electrical work, and second one is the mechanical. Let us see. First one, that is the electrical work. चलो, electrical work में क्या होता है कि here the iron is there. What is that? The iron. Right? Electrical work is important in the reaction between ion in the system. Right? So I can write down electrical work. Electrical work is what? Important in the reaction between, important in the reaction between ion in the system. Right? अगर ion के बीच in the system कोई भी आयन है और उनके बीच में जो केमिकल रिएक्शन होती है ना, तो उसको उस टाइम जो भी वर्क होता है ना, उस वर्क को हम कहते हैं इलेक्ट्रिकल वर्क. राइट? ड्यू टू द ट्रांसफर ऑफ आयन. नाउ मैकेनिकल वर्क इज इंपॉर्टेंट इन विच ड्यूरिंग अ रिएक्शन देयर इज अ चेंज इन द वॉल्यूम इन द प्रेजेंस ऑफ एक्सटर्नल प्रेशर. अगर मैं एक्सटर्नल प्रेशर अप्लाई करता हूं तो उसका वॉल्यूम चेंज होगा, एंड दैट वर्क इज सेड टू बी द मैकेनिकल वर्क. सो नेक्स्ट वन, दैट इज द मैकेनिकल वर्क. मैकेनिकल वर्क, चलो किसको बोलते हैं? मैकेनिकल वर्क, दैट मीन्स इट इज इंपॉर्टेंट इन विच ड्यूरिंग रिएक्शन देयर इज अ चेंज इन द वॉल्यूम. इट इज important, right, during which, during the reaction, right, there is change in the volume, there is change in the volume by applying external pressure. Right? In the presence of external pressure, in the presence of external pressure. Right? When I apply the external pressure, then we can say that the volume of that particular container will be changed, right? And this system which possesses gaseous state, for them mainly mechanical work is important. For gaseous state, gaseous state में क्या important है? Mechanical work. Understand? Is it clear? If the gaseous substance are associated with the chemical reaction, then there is a change in the volume in the most of the reaction under the constant external pressure, right? And if the volume of this type of system increase during the reaction, then the work is done by the system. If the volume right, if the volume of this type of system increase, then work is done by the system. Then, right, increase during the reaction, then we can say, then during the reaction the work is done by the system. Then work is done by the system, right? And if the volume decrease, then work is done on the system. And if the volume decrease, then the work is done. On the system. अगर कोई भी सिस्टम है और अगर वो वॉल्यूम इंक्रीज करता है, तो दैट इंडिकेट दैट वर्क इज डन बाय द सिस्टम. एंड इफ द वॉल्यूम विल बी डिक्रीज, then the work is done on the system. Understand? Let us suppose, if we take the example, if the initial volume of the system, initial volume that is V1 and final volume is V2, final volume that is V2, right? External pressure is P, external pressure, we can say it is a P, right? Is applied on the system, right? Then the work done by the system due to the change in the volume can be shown. The work done by the system, then work done by the system, that is W equals to P into V2 minus V1. So I can write down here that W equals to P into delta V. Understand? So why? Because the work is done by the system. Is it clear? Now, if work done during the reaction is only PV, if work done during the reaction is only PV, right? Then PV type work is there. So we can say that Q equals to QP and Q equals to QP. And if the work is done by the system, then, and if the work is done by the system, then I can say that W equals to minus P into delta V. Why negative? Because work is done by the system. Understand? So I can write down here that according to the first law of thermodynamics, delta U equals to Q plus W. So I can write down delta U equals to Q minus P into delta V. Understand? Right? Now, here, but if there is a no change in the volume of the system, if the volume is constant, then delta V equals to 0 at a constant pressure, at constant pressure. So when the pressure is constant, this term will be 0. So delta U equals to QP. So I can write down here that at a constant pressure, the change in the heat, that is called the change in the internal energy. Understand? The we can say that at a constant pressure the heat is received by the system or heat is lost by the system. At a constant what the heat is received or at heat will be lost, and this is not constant pressure but the volume will be constant. Understand? So it is indicated by the QV. Understand? So note down all the things, work and the first law of thermodynamics. चलो नेक्स्ट देखते हैं एंथैल्पी एंड फर्स्ट लॉ ऑफ थर्मोडायनामिक्स. Let us see. Enthalpy means what? H, right? So now let us see that enthalpy and first law of thermodynamics. Enthalpy and first law of thermodynamics. See here, we can say the chemical reaction is occur in open vessel at a constant pressure. कोई भी जगह पे हम केमिकल रिएक्शन करते हैं ना तो वो ओपन वेसल में होती है, और ओपन वेसल में प्रेशर क्या होता है? कांस्टेंट, दैट इज अ 1 bar, राइट? सो आई कैन राइट डाउन द केमिकल रिएक्शन occur in open vessel. The chemical reaction occur in open vessel, right, at constant pressure, at constant pressure, right, at constant pressure. Now a new state function has been defined, that is a change in energy occurring on this type of process, and this state function is said to be the enthalpy, right? So I can write down a new state function. A new state function has to be defined at constant for change in energy, right? Okay, occurring on this type of process. So the new state function is called enthalpy. This new state function is called, इसको क्या बोलते हैं? Enthalpy. Enthalpy, that is called H, right? So I can write down the relationship between the enthalpy and internal energy. Relation between enthalpy and internal energy, that is H equals to U plus PV. Now here, if there is a change in the states of system, the change in the enthalpy can be shown by, let us see, that delta H, that is equals to delta U plus delta PV. Understand? So I can write down here this way, that delta U plus P into delta V plus V into delta P. But if the reaction occur at constant pressure, if the reaction occur at constant pressure, then we can say delta P, that is equals to 0. So I can write down delta H equals to delta U plus P into delta V. Understand? So this is the change in enthalpy of the reaction. Now, but according to the symbolic equation, first law of thermodynamics, if the reaction occurs at constant pressure, then the work done by the system is only PV type, right? So Q equals to what? QP. Okay. So I can write down here work done by the system. If the reaction occurs at constant pressure, if the reaction occur at constant pressure, right, then work done by the system is only then work done by the system, right, is only of PV, is only of PV. Understand? And so we can say, and so Q equals to QP. Understand? And W equals to minus P into delta P. Why minus? Because work is done by the system. So I can write down here that Q delta U equals to what? Q plus W. Q plus W. Put the value. Delta U equals to QP minus P into delta V. Understand? So I can write down that delta H equals to delta U plus P delta V. Put this value over here. This is equation number 1. This is equation number 2. From equation 1 and 2, from equation 1 and 2, I can say that delta H equals to, instead of delta U, put this value, QP minus P into delta V plus P into delta V. These two will be cancelled out. So delta H equals to QB. So I can write down here, at constant pressure, the heat release or heat will be gained, absorbed. That is called the change in the enthalpy. Understand? So thus the change in enthalpy of the system in which the chemical reaction occur at a constant pressure is equal to the value of heat gain or loss by the system. Understand? So I can write down thus how you can define the change in the enthalpy of the system. The change in the enthalpy of the system at in which chemical reaction occur, in which chemical reaction occur, then at constant pressure is equal to the, at constant pressure is equal to the what? Value of heat gain or loss by the system. Value of, yes, here, heat gain or loss by the system. Understand? So this is how you can write down. This is the, at a constant pressure, the heat gain or loss by the system, that is called the change in the enthalpy. Understand? So write down all these things. Okay, now last point, that is the moles and first law of thermodynamics. Moles and first law of thermodynamics. Let us see here, mole and first law of thermodynamics. See here, first of all, if the number of gaseous molecules of the reactant is changing because of a chemical reaction and the reaction is occurring at a constant pressure, then the volume of the system is also changed, right? I can write down, if the, we can say, number of gaseous molecules, number of gaseous molecules what of reactant is changing, of reactant is changing, right, because of chemical reaction, because of chemical reaction, okay, because of chemical reaction, and the reaction is occurring at constant pressure, and reaction is occurring at constant pressure, right? Then the volume of the system is changed. Then the volume of the system is changed. Understand? Is it clear? Suppose the volume of the system has n1 mole. Suppose the volume of the system has n1 mole. Suppose let in a gaseous reactant at a constant pressure P, in gaseous reactant at constant pressure P, at constant pressure P, and the volume and constant temperature is T, and constant temperature is T. Is it clear? Now here we can say that now if the constant at a constant pressure and constant temperature, the volume of n2 moles of gas is V2 at constant pressure and temperature, we can say that the volume of n2 moles of gas, the volume of n2 moles of gas is V2, right? Then according to the ideal gas equation, according to ideal gas equation, chalo, ideal gas equation means PV equals to nRT. Understand? Now you all know that PV1 equals to N1RT and PV2 equals to N2RT. Now V2 minus V1, so I can write down PV2 minus PV1 equals to N2RT minus N1RT. So V2 minus V1 equals to RT N2 minus N1. Is it clear? So I can write down here P into delta V equals to delta Ng into RT. Now what is delta Ng? That shows the difference between total number of moles of gaseous product and total number of moles of gaseous reactant. Understand? So I can write down delta Ng, that is equals to Np minus Nr, moles of total moles of product, અને यहाँ पे हम लिख सकते total moles of what? Reactant. Understand? So this is the delta Ng. Now according to the change in the internal energy, I can write down here that delta H equals to delta U plus P into delta V, right? So I can write down delta H equals to यहाँ पे delta U plus delta NGRT. This things is the most important thing for the examples. Understand? You have to know. Now if the total number of moles of gaseous reactant and product is same, if total number of moles of gaseous what? Reactant and gaseous product, reactant and product are same, then we can say delta Ng, that is equals to 0. Then delta Ng will be 0. We can say that delta H equals to delta U. This is the first thing. Second, if total number of moles of gaseous, if total number of moles of gaseous what? reactant is more than reactant is more than total number of moles of gaseous product, total number of moles of gaseous product, then we can say that delta Ng is less than 0, and thus we can say that delta H is also less than delta U. And the last one, that if total number of moles of gaseous product is more than gaseous reactant, then delta Ng greater than 0, so delta H is also greater than delta U. So all these things you have to know very well, right? So this equation, with the help of this equation, you have to solve. The examples are given, right? Any chemical reaction, you have to find out the moles. R, that is a gas constant, T is a temperature, and delta U, that is a internal energy. Okay, so up to here it's enough. Now tomorrow we are going to discuss about second law of thermodynamics, right? And some examples related to this, that is work and first law of thermodynamics. Then we can say second one, that is enthalpy and first law of thermodynamics, and moles and first law of thermodynamics. Okay, so up to here it's enough. Thank you very much.